All right, welcome here to Chapter 8. Chapter 8 is on exponents. We had a little bit of review of that in first semester. But what I like to do is to start this all off and say, as we welcome you to the exponent properties, what we need to do is make sure we understand what a power is, what a base is, and what an exponent is. So if I gave you an example of something like x raised to the n power. Well, what we know here is that we can define the x as being the base. We know that the n is the exponent. It is this superscript. It's a small number that's written up high. And together, this whole thing, the base and the exponent, make up the power. So let's look at an example here, all right? I'm going to give you something like, let's say, 3 raised to the 4th power. Well, my base is 3. My exponent is 4. And the power is 3 raised to the 4th power. But what does 3 to the 4th power mean? What this means is that we are going to multiply the base by itself 4 times. And I like to emphasize this because when we understand what an exponent is, it will make some of these rules that we are about to see start to click and make a little bit more sense. Early on, I tell some of my students, don't worry about memorizing the rule. Make sure you understand what is going on. So we'll do some of these problems a number of different ways, with using the rule and without using the rule. But the first group of problems we're looking at here is what is called the product rule. And the product rule says that when we have a base to a power times the same base, a to a power, that is going to be equal to keeping the base the same, and we add the exponents. But I'm going to first look at problem number 1 and say, you know what? 2 to the 3rd times 2 to the 2nd, we are going to write without exponents. And if we do this, what we start to recognize is that 2 to the 3rd is 2 times 2 times 2, 3 times. 2 squared is 2 times 2, 2 times. And if I count this up, I understand here that I get 2 to the 1, 2, 3, 4 to the 5th power. Well, let's go back here and look using the rule. What the rule here says is that we can keep the base 2, because that's what our same base is, and we're going to add 3 plus 2 and get 2 to the 5th. Either case, the answer is the same. If you do have your power sheet, we can evaluate 2 to the 5th and remind you that that is 2 times 2, which is 4. So, and then times another 2 is 8. And then times another 2 is 16. Times the 5th time of multiplying 2 by itself to be 32. But I would like to emphasize the idea of that base. When we look at the next problem, again, I'm going to look at this. As x times x times x times x 4 times being multiplied by x times x times x. And what I recognize here is that I end up with x is my base, that's the same base, raised to, if I count those, that is 1, 2, 3, 4, 5, 6, and 7. If we come back and say, hey, you know what, they did teach us this rule, and if I use the rule says that if my base is x, I'm going to add those exponents together, and I'm going to get x to the 7. Let's do one more like that. And over here in problem number 3, we get negative 3 being multiplied by negative 3 2 times, and then being multiplied by another negative 3. Well, I know that my base here is negative 3, and if I count them up, that's 1, 2, that's negative 3 to the 3rd power. So that's negative 3 times negative 3, which is 9, and 9 times negative 3 would give me negative 27. When we take a look at using the rule, please recognize here that my base is negative 3, and it's the exponents being added together, which is 2 plus, they don't give us an exponent here, but that unwritten exponent is assuming that that is negative 3 to the 1st power. So negative 3 raised to the 2 plus 1 power is negative 3 to the 3rd power. which is again also equal to negative 27. These next three, problems 4, 5, and 6, I am not going to, expand it all out. But what I am going to do is look at applying the rule. I get 4 times x to the 5th times 2 times x, that is to the first power. What I recognize here is that I have 4 times 2 being multiplied by x to the 5th being multiplied by x to the 1st. Well, I know 4 times 2 is 8. We're going to just multiply those numbers. That's multiplying coefficients due to the commutative property. And then that's being multiplied by x to the 5 times x to the 1 is 5 plus 1, which is x to the 6th. Likewise, in problem number 5, we're going to multiply together the 3 and the 6 because they do not have exponents on them. And we're going to look at x to the 2nd and x to the 4th. 3 times 6 is 18. X to the 2 plus 4 is going to give me 18 times x to the 6th. Problem number 6, we kind of move it up a whole nother level here, and we say, whoa, we don't just have x's here, we also have y's. But that's okay, because I'm going to multiply negative 5 times 7. Those are the multipliers, or the coefficients. I'm going to multiply together the x squared with the x cubed. That's the same base as x. And we're going to multiply together a y to the 1st being multiplied by a y to the 8th. Let's first start with the negative 5 times 7. That is negative 35. X to the 2nd, x to the 3rd is 2 plus 3. So that's x to the 5th power. And y to the 1 plus 8 is y to the 9. As we look at the quotient rule is going to say we are going to take a base, raise it to a power, and that's divided by the same base, in this case a in the rule, being raised to a power. What the rule says is that in a scenario like this, we are going to keep the base the same and we subtract the exponents. But let's go back to the very, very basics here, because what I like to emphasize is you guys back in pre-algebra became aware that if I have a fraction, what you're allowed to do to simplify a fraction is to reduce by canceling common factors. So I know that 7 divided by 7 is 1, and 7 divided by 7 is 1, and 7 divided by 7 is 1. So what that leaves me is 7 times 7, which is 7 squared, or 49. I'm going to move this so I can come back and do it using the rule here in a second. If I look at this problem using the rule, well, as I look at this, the rule says that if I have a base of 7, what I'm going to do is keep the base 7, and then I'm going to subtract the exponents, subtracting the numerator minus the denominator. 5 minus 3 is 2. 7 squared is that same 49. This next problem, I'm going to explain it out. It's going to take a little bit longer because we're going x to the 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by x to the 4th. And again, you're allowed to cancel common factors. I'm going to use a different color so it's a little bit easier to see. But x divided by x is 1. X divided by x is 1. X divided by x is 1. We're going to cancel 4 factors of x's in the numerator with 4 factors of x in the denominator. If I count this up, what I'm left with is x to the 5th. If I look at that rule, the rule says that I get x raised to the 9 minus 4 power. 9 minus 4 is x to the same 5th. Again, you have to figure out what you're comfortable with so that you can do this. I'm going to move on here to number 9. In number 9, we do have to worry about that this is a division bar. If that is a division bar, we have to first simplify that in the numerator. Well, if we remember from before, again, I can expand it out. And that's 6 times 6 times 6 times 6 times 6 multiplied by 6 times 6 times 6, which is going to give me 6 to the, if I count all those up, that is going to be 6 to the, what do we get there, 8th, divided by 6 to the 7th. And when we do that, 8 of those divided by 7 of them in the denominator is going to give me 6 to the 1st. Again, if you're not sure. 1, 2, 3, 4, 5, 6, 7, 8. Divided by 7. Again, I'm going to switch and cancel the factors. 6 divided by 6 is 1. 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 We're going to do that all the way across until we got 1 left over 6. So that's 1 extra factor of 6, or 6 to the 1st. If I would like to use the rule, starting with the problem we said was 6 to the 8th divided by 6 to the 7th. Remember, we can do it as a basis 6 to the 8 minus 7, which is 6 to the 1st. In problem number 10, I'm going to focus on using the rule here. This here is going to be a fraction of x to the 10th over 1. So when I do this, I get x to the 10th divided by x to the 3rd. In this situation, the base is x. We can subtract those exponents and get x to the 7th. Problem number 11 and 12 grow in complexity, but let's use the rule first with the x to the 7th and the x to the 3rd. If I want to simplify this, we need to figure out that if I have a base of x divided by a base of x, what we're going to do with those exponents is to subtract them. 7 minus 3, and then we're going to leave the rest of the problem alone. This is going to give me x to the 4th. When we get to here, there is one more thing we'd like to do, and that is if I have a fraction, something like 15 divided by 5, the common factor that goes into both of those is 5. So what we know here is 5 goes into 15 3 times, 5 goes into 5 once, and our final answer here can be 3 times x to the 4th, y to the 3rd. And again, moving it up one level of difficulty in problem number 12 is that, again, I'm going to leave the 40 and 16 for now. But I do want to look at this x to the 1st divided by x to the 1st. So that's the same base of x, and we're going to subtract those exponents. So 1 minus 1. I'm also going to look at the y's. And if I have y to the 9th and y to the 3rd, again, we're going to subtract those exponents. I'm going to be left with 40 divided by 16. That's x to the 0 times y to the 6th. Well, we are going to be noting this later, but this x to the 0 will become equivalent to 1. So we can ignore it, because what that's saying is that there are no x's there. Because likewise back here, I'm going to highlight this in yellow. But if I have x divided by x, x goes into x once, x goes into x once, which is why we can say that those have canceled out or reduced to be 1. So we are then going to be left with 40y to the 6th divided by 16, and we need to find the common factor that reduces the fraction 40 divided by 16. That common factor that goes into 40 and 16 is going to be 8. So we're going to divide each of those by 8, and we divide each of those by 8. We know 40 divided by 8 will simplify to be 5, y to the 6th, and 16 divided by 8 is 2. This is kind of, a little bit of, would I say, like problem solving. This is kind of like, what is that missing exponent? So what we'd like to think in our head is, as we saw in that last problem, if I put that as p to the unknown divided by p to the 5th, and what would that have to be for a question mark in order to equal p to the 9th at the end of the day? But what we want to do here is think about this and say, well, this is a quotient of powers, and if I have a quotient of powers, it's p to the I don't know, minus 5 equals p to the 9th. And then we just need to think about what would that exponent have to be so that if I subtracted 5 from it, I would end up at 9, and that would be 14. I know that there's some people that would be doing this problem using, like x as a variable. That is okay as well. Problem number 14. If I take a look here, what does it mean to square something? Well, to square something, that means that I get 2p to the third multiplied by 2p to the third multiplied by p to the question mark, p to the question mark, and p to the question mark. And again, we would like that to equal 4p to the 18. Well, let's take a look here. I get 2 times 2 is 4. This is p to the, if I combine these here, p to the third and p to the third is p to the 6th. And then I get p to a question mark, p to a question mark, p to a question mark. And we want that to equal p to the 18th. Well, got to do a little bit of problem solving here and saying, well, let's say if this is each going to be like a p to the 1 and p to the 1 and a p to the 1, that would give me 3 more, and 3 and 6 is only 9. And then you say, well, maybe the question mark is 2. So 2 and 2 and 2 and 6 is 12. So what number does that question mark have to be? Well, that all comes down to this idea that we get p to the 6th plus question mark plus question mark plus question mark equals p to the 18th. And as we'd like to try to find this here, we're going to end up getting that that question mark would have to be equal to, magic number is 4. And the reason for that is because 4 plus 4 plus 4 is 12, plus 6 would equal 18. All right, and then we get to problem number 15. In problem number 15, what we're looking at here is that we get 2c to the third divided by d squared multiplied by 2c to the third d squared. And we need to figure out how many times we'd have to do this so that we could get to 16 c to the 12th d to the 8th. Well, right now, if I look at the c's, I'm only at c to the third. If I do it another time, I'm going to be c to the third, c to the third, and c to the third to c to the 9th. If I do it another time, I'm going to be at c to the third, c to the third, c to the third, c to the third, which is c to the 12th. I could also look at the d's. D squared, d squared, d squared, d squared, add up all those exponents, 2 plus 2 plus 2 plus 2 would in fact give me 8. So what we know here is that how many times did we do that? We did it 4 times, which tells me that question mark is again equal to 4 in this problem. I really like the way problem number 16 works out here because it says let's write equivalent expressions using products and quotients, and you got to use one of each that are equivalent to 12x to the 8th. Well, I'm going to make a note here and say answers may vary, because I might recognize that I see that 12 there is 2 times 6. I might also recognize that x to the 8th can be broken up as, say, like x squared and x to the 6th. And the reason for that is because that's xx, and then that's xx, 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 and if I count all those up, that's going to give me x to the 8th. I could also look at this as a, say, quotient. So can I divide some numbers that would be equivalent to 12? For sure, I could look at, say, like 24 divided by 2 would be 12. And then can I look at some bases of x so that if I subtract their exponents, I'd end up at 8? I could have like 20 subtracting 12 would allow me to end up at 8. And again, this is like your quick check. All right. Let's look at one last one over here. I'm going to do another multiplying here. And what I'm going to do is recognize that 12 could also, say, be like 3 and 4. And I can do it as x to the 5th. And then this would have to be x to the 3rd would be the correct answer. Because that's 5 of them. That's 3 more of them, which is going to give me x to the 8th. And last but not least, in this challenge problem down here, I really like the way this one plays out, because if I take a look at this first part, that's the b to the x divided by b to the y equals b to the 9th. What I remember is that I can subtract these exponents, and that's going to be equal to b to the 9th. Well, if my bases are equal, I know that the exponents then would have to be equal. I'm going to mark that right now as one equation. I'm going to also look here, grab the other color here, at that there. So I have b to the x times b to the 2nd divided by b to the 3y equals b to the 13. Well, let's deal with this up here first. That's b to a power times b to a power. This is a power of, a product of powers, which is going to remind me I get to add those exponents. I'm going to then deal with the fact that this is a quotient. So a quotient says that I can take the b to the x plus 2 and subtract the exponent from the denominator, which is minus 3y. And then again, if these b's are both equal, I know that the exponents would have to both be equivalent as well. And we can set this up, clean it up a little bit, and we get x minus 3y equals 11. And that there is my second equation. I'm going to put a note. We have two unknowns, x and y, and two equations. This is a review from chapter 7, so this is solve this system. So I'm going to put my system over here. So this is x minus y equals 9. This is x minus 3y equals 11. I think the easiest way to do this problem for me, the way it's laid out, is to use what is called linear combination. If I do that, I am going to multiply the bottom equation by -1. The reason I do that is because then I'm going to get -1x plus 3y equals -11. I'm going to add these two equations together. Here the x's cancel, which they should, because I said my goal is to eliminate the x's. -y plus 3y is 2y equals -2. Divide by 2. Y is equal to -1. I'm going to plug into the top equation. And if I do that, I get x minus -1 equals 9. Subtract 1, so x is equal to 8, which tells me if I'm going to try to find x and y, I know that x is equal to 8 and y is equal to -1. Oftentimes in chapter 7, we wrote it as an ordered pair representing x and y, but that there would be your solution. You can always plug that in to double check. All right, that would be a wrap on day number 1.